Now, yes.
My notebook's in my binder.
Oh, do you want to grab it? Please come back with me. Okay, thank you. No worries.
Oh my God.
Now, guys, today I just gave you a handout, and this handout is going to cover this session and also the next week session, and also a huge chunk of your homework, which you're just gonna finish it by in the middle of the next week. Yes.
What days are testing?
It's November the 2nd. It's going to be it's a kind of a quiz. It's very easy, 30 minutes content quiz. That it's not like a test. It's very short quiz. Now, before we start, I'm just gonna start in this handout that we have. You have two different sections. Section 2.6, which is going to be covered today, and also section 2.7 that we are going to cover next week. For these 2 weeks, we have a motto. We have to just follow this. Our motto is KISS. You know what does it mean, KISS?
Candy.
Huh?
The chocolate.
The chocolate. No, this one means, this one stands for keep it
simple.
simple
I got it.
and short.
Oh, that's true.
Short and simple.
This is actually the motto we are going to follow, not today, and also early next week. Then whatever we are going to do, Rodwood, is that you look at an expression in algebra and say, oh, Matthew, it's a KISS. We have to keep it simple and short. Now, what do I mean? Before we just start, I just want to ask you, for example, imagine I have an expression. In the past, the session that we had before, we talked about the rational expression. When we talked about the rational expression, we said that if you have 2 polynomials, they are being divided. We said that the first thing that we do, for example, look at this one. X to the power 2 minus 1 over x plus 1. It's a kind of a review of what we did last week. We said that if we are going to, for example, you are just standing in your house, somebody comes, knocks at the door, they offer you this rational expression. What do you then? The first thing that you do is that you open the box. What do I mean by opening the box? You remember that you just focus at the basement of your expression. And you say that, okay, from here, I come to this conclusion that the basement, which is my denominator, should not get 0. Then I take it equal to 0. Then I solve this expression, which is the denominator of that thing. Then it means that x equal to minus 1 is the root of my rational expression. It means that if I put minus 1 inside this thing, it takes its denominator equal to 0. And that becomes the thing that becomes very scary. When we have a rational expression, its denominator is 0, we have to scream Lucas and run away. That's what we do. Then as a result, we learned that from yesterday. We said that as a result of this, we say the domain of f of x, it can be any numbers. X is any real number, however, x should not be equal to this disastrous number. It's a problem minus 1. Then I'm going to exclude it. And that's what we covered. That's what we covered last session. However, if you remember, yes, Jane. Oh yeah, absolutely. These are just some kind of symbols we use in math. You can choose anything else. But that's totally fine, Jack. Good question. Now, guys, and now look at this. Everyone is okay so far with this?
Yeah.
Now? And now look at this, what's going to happen. Now probably you, for example, you For example, now Lex is going to ask me, oh, I'm looking at this rational expression. This rational expression will come in two parts. Let me. This rational expression comes, in two parts. And one is the numerator, and the other one is the denominator. Now, Lex is going to tell me, I got an idea, and the idea is this. I can rewrite this in this format. I write x minus 1 as x plus 1 times x minus 1. And if you ask Lex why you decided to write this like way, maybe I should say, Daphne says, because I know this expression. Because I know that a plus b is an expression. Elisa, it comes with two terms, a and b. Then Elisa says that if I multiply that to the same thing, which only differs from one minus in between, then we learned that last time. We do not have to come to say, okay, a times a plus a times b, b times a, b times b minus. We do not need to do that. We simply close our eyes, we write a squared minus b squared. And that's the conjugate identity. Easy. You close your eyes, you write a squared minus b squared. Yeah. No trouble to just do this kind of multiplication. Now, I did the same thing over here. X squared minus 1 is essentially x plus 1 times x minus 1. You say, why? Jonas is going to tell you because of this. Yes? Because x minus 1 is x plus 1 times x minus 1 is x squared minus 1. As you get that. Yes? Now, I have also, at the denominator, I have x plus 1. Now, look at this. And now, Matthew is going to be surprised because we look at this. We see x plus 1 times x minus 1 divided by x plus 1. We say that, okay, we follow this rule. Keep it short, rather, and simple. It means that when I have two terms, one on the top, one at the bottom, I kiss it. It doesn't mean I kiss it with my lips. I make it short and simple. Huh? Yes?
What's the point of finding?
What point of finding the domain?
Yeah, like we're not using it.
I'm going to tell you in a second. When you plot it, oh my God, this becomes a lifesaver. The whole life of your life in function and in math is because of if you identify a domain correctly. At least a good question. You are going to see that in future a lot. Now, when you see this one, these two terms, x plus 1, similarly on the top, and x plus 1 at the bottom, we keep it short and simple. What do? They are the same. I cancel them out. And what do I get at the end? That's right. I just want to say that's so true. But I thought, okay, let's choose a different expression this time. It becomes x minus 1 now. And now you say, what's the point? I started with a rational expression. I kissed it. By kiss, remember, by kiss I mean keep it short and simple. I kissed it, then it becomes x minus 1. And now, from a rational expression, I have a polynomial, a binomial. But remember, as we finished it last time, before we end the period, I said that before you start kissing the rational expression, make it short and simple, always make sure that to find the domain by finding the restriction, because we said that x minus 1. Anything rather which takes denominator to 0, we call it a restriction. Yes?
So you see x minus 1, what is that? What is that?
This is still f of x.
So we're just solving it? It's
But you kissed it.
Okay, so it's just f of x. So if the question asks, what would the question be asking? It would be asking to simplify the.
That's right, to simplify that.
Okay.
But we call this in this class, we kiss that expression, but it has to simplify that version because you are going to use it. I'm going to use that result now to start today's lesson. And then, look at this. Yes.
You just don't use the domain?
No, we just use the domain. From the first time, I mean that, for example, Elisa, you are sitting at home, somebody knocks at the door, you have an envelope. You open it, you see, oh, there is an rational expression in there. You close your eyes, you find the domain right away by finding the restriction. Then you kiss it. After you find the restriction, you come to short it and simplify it.
Is the domain always going to be the same as the simplified version?
No, that's good. That's a good question. Because I said you find the domain or restriction, Lisa, before you kiss the expression, you find the restriction, then you kiss it.
Well, why do you need to find the restriction? Like, we're not even using it.
Because if you do not find the restriction, when we go a little bit further in the course, you see, oh my God, life is going to get so troublesome. We need this one at this stage, we use it in a little future.
Oh.
Yeah? But look at this. But when you kiss the expression, as Lucas said, if you find the domain is R. Because there is nothing that takes the denominator goes to 0. But I say that do not let you fall in this trap. Always find the domain before you kiss this expression. Because now if you want to find the domain here, this is wrong. That's right. Always find the restrictions before you simplify your expression. Now, it is the thing that we reviewed. I reviewed these things essentially. There are the things from session that we previous period. Any questions so far? No, everyone is good?
Perfect.
Nice. Now, I'm just going to use this and come here to say, okay, for example, I say f of x still is going to be that expression. Now we are going to start a new session, x plus 1. And I also give you another rational expression. The new rational expression is going to be this. Okay, it's going to be x squared. Let me make it fancy. Use two different colors. Now, please guys, make sure that while I'm just like the new topic for you on the board, you take a look back again on this thing here and make sure that you have no question at all. Now, I'm just going to write the g of x now. Yes.
But yesterday or last time we did that and then we looked at the domain instead.
Even after we kiss the expression?
Yeah, after
After
we simplified it.
we simplify that, if you can find the domain from here, the domain from here is essentially all real numbers. But that one is an illusion because this domain doesn't make any sense. We always, as a rule, we find the domain. For example, I'll give you one example. Guys, everyone please look at this one. This is a trap. I learned it took for me many years to learn this one. That's why I should not use this one. Now look at this, Janaya. Look at this. For example, look at this first expression. Imagine this is me. This is only this expression. Next week, I come to the school. I have the plastic surgery. I implanted some hair. And I have, for example, I have some gels on my hair, and I look totally different after the plastic surgery. This is me after plastic surgery. But still, I'm the same man. Still, my name is Omid. Still, I'm a math teacher, and it didn't change anything. Then, if you just want to look at me after the plastic surgery, you have to always remember me who was under this scheme, which is still Omid with the glasses with ball. You know, that's going to be still me. And that's the reason we never look for the domain when we do the plastic surgery. Yes?
So are you going to ask us to compare the domain to the workbook?
we do not ask you to compare, but we ask you to find the restrictions. We ask you in the questions, for example, on the quiz next week, for example, November 2nd. We ask you to find the restriction of such an expression, and we are looking for to see that if you keep this expression first, then you don't appear in the domain, which you lose mark then. Make sense? No problem. Now, and now look at this. Why did we, any other questions, guys? No, everyone is happy, happy, happy? Yes. And I think that I have to just here to just tell you something about a new topic. Now, let me see. Wow. Guys, look at this part now. Why did we bother to talk about this? Now look at this. We have now f of x, and now we have g of x. Before I ask you, what is the restriction? Both of them are rational expressions, because both of them are the ratio of two different polynomials. The first one, it had a restriction x minus 1. And the second one has a restriction that x to the power 3 plus 1 should not go to 0. Which you see that if x is minus 1 again, x goes to 0. This one goes minus 1 to the power 3 becomes how much?
Oh, minus 1.
Minus 1 plus 1 becomes 0. Then you see that for both of them, just by accident, both of them have the same restriction. Now, I come and say, okay, now, just for having some fun, for example, at this stage, I think for having some fun, we say that f of x times g of x. You multiply them together to see if something interesting happens. Just Celia? Interesting, huh? Glad to hear it. Now, and that's the plan. Let's, for having some fun, multiply them together. Let's see what happens. The expression for f of x is what? X squared minus 1 over x plus 1. Let me see if I'm still on the camera, if I just go that far. I'm still there. Now, the expression for g of x, what is that? The g of x is x to the power 2 plus 2x plus 1 over x to the power 3 plus 1. Now, we are going to have fun. That's the reason that we are doing this. In order to multiply, to remember this rule, let me write this rule here. Let me erase this. To remember this rule, when it comes to multiplication, you say that, for example, 3 times 6 times, for example, 7 times 9. There are two numerically evaluated rational expressions. You want to multiply them together, you say, can't be, it couldn't be easier, because I multiplied. The people who are facing together, it seems that they are going to fight. The people who are at the top, they are just going to fight. It means that 3 times 7. And the people who are at the basement, they are just going to fight with itself. It means that you are going to multiply them directly. That's the rule that we noticed from a couple of years ago. Yes, everyone?
Yeah.
Yes, Matthew? And the same thing applies to this. And if I want to do this, I do what? I say, I write x squared minus 1 times x squared plus 2x plus 1 multiply, and in the denominator I have x cubed plus 1, which is also x plus 1. So far, so good, everyone? Yeah. Nothing is fancy yet. We are reviewing the things from years ago. Now, we also learned that yesterday, the session before, that we can find the numerical value of a rational expression. For example, if f of x is expressed like that, I come in the test, for example, I ask you from here, what is f of, let's say, 0? What is f of 0 there? That's right. Whenever you see x, you remove it, you plug 0. Then it becomes minus 1 over plus 1 becomes minus 1. Now, in this case, imagine that I'm going to ask you to find f of 4 times g of 4 when this is multiplied. It means that you have to come here and look at this. Put 4 here, 4 to the power 2 becomes 16 next, minus 1. It becomes too much work. I don't like it. Sweating, I don't like the idea. It's too much work. You just want to find the expression and evaluate that 4. Oh my God, you have to put 4 on every single term, multiply this to that term, divide it by that term. Life should not be that hard. Then what to do to make the life easier? Get a question? What to do to make the life easier? And essentially, this one is the lesson for today, to make your life easier. Now, in order to make your life easy, you have to again use the rule KISS. Now, you look at this one, before you plot 4 at the x, you kiss that expression. Not physically, but I mean keep it short and simple. How to do this? Huh? That's right.
Hello.
Lovely for you guys to show up.
Thank you.
Okay, now, and it's good to have you back.
What?
Let me just keep it in hand out. Guys, please make sure that you watch the first 2 minutes on the recorded session today, which is going to be on the Google Classroom. Thank you. Now, guys, please everyone. And now we are just going to kiss this expression. How to kiss this expression before I just put 4 or 5 inside this. In order to kiss any rational expression, we use the factorization method. Look at this. We kiss this one. We factorize the terms, then we kiss them. We make it short and simple. I'm going to do the second method.
Why don't we simplify?
What?
Yeah.
That's what you're going to do. That's why you're going to kiss it. Now, guys, look at this. I'm going to try as much as I can, factor everything in there. I look at x squared minus 1. No problem. We know that how to factor this one using the conjugate method, which I erased it from there 2 minutes ago. X squared minus 1 is essentially what? X plus 1 times x minus 1. Now, I have x plus 1 and the denominator there. I have x cubed plus 1, part of the g of x. And when I look at the one which I just wrote that in red, I can remember of something. And that thing is this. I remember a year ago.
A minus b squared equals b squared.
That's right. I want to say that's so true, but I'm going to find a new expression to use.
No, I like that expression.
Okay, look at this. A plus b, if it goes to the power 2, I just close my eyes and I see the a squared plus 2ab plus b squared. I do not need to just expand it, multiply term by term, then add them together. Just close your eyes, use this identity, you get the result. And look at this one. X squared plus 2x plus 1 is somehow similar to this. I have something which is squared. 1 squared is the 1 itself, and 2 times of something. It reminds me, I got it. It should be something similar to this. Then if I investigate, I see that I can write x plus 1 to the power 2. That's because if you expand x plus 1 to the power 2, look at this. As an example to this, x plus 1, Elisa, to the power 2. I use this part. It means that the first term goes to the power 2, x squared.
I mean,
Yes.
to avoid any other like exponents, can we just write like x plus 1 twice?
Yeah, you can do that, of course. And now you see that 2 times AB. What is my A? What is my B?
1.
That's right. 2 times AB becomes how much? That's right. Plus 2x plus, what is my B1? B squared, which is 1. And convert this for the Lisa with this.
Oh,
And that's why you write it like that.
I get it.
You got it? I'm so glad. Now, guys, look at this. Now, this is the time that we can piece this expression. Keep it short and simple. How?
Sir,
Yes.
if you just simplify from the beginning, it's the same thing.
Yes, but I just wanted to show that everyone. That's how we go. Now, guys, look at this now. To the expression that we have, well, I'm going to kiss it. Look at this. X plus 1, x plus 1. What that one? I can cancel this out.
That is so true.
I have x minus 1. So true. Then I have what? I have this expression. X minus 1 times x plus 1 to the power 2 times x cubed plus 1. Then you see that we are able to factor this. You can still, oh, sorry guys, I hope that you see this at the back. You see this, huh? Nice. I wanted to, yes, Lucas.
If we write x plus 1 at the top, if you just write x plus 1 times x plus 1, is that still correct?
That's still correct.
Okay.
Guys, you can still continue further. You can still simplify this, x cubed plus 1. I'm not going to do that here because it's going to be for a little bit more advanced, because I don't want to get you confused, but we stop here. We say that now we multiply these two terms, f and g, and we could, look at this, we could stop here. And that's the result of multiplication. But we were able also to simplify that and we kiss it before we end it. And as Matthew said, you may say, okay, here I can simplify the terms. X squared minus 1 is still x plus 1 times x minus 1. You cancel this right away from there. Either you multiply them, you cancel it, it's just from there. And that's the thing which we do. We multiply, then divide. Now, yes?
Why is x minus 5?
Oh, we can take it out because it doesn't matter. Look at this. For example, AB divided by C is like we write AB over C because A is still multiplied with this. It looks a little bit cuter when you like it. Now, guys, now you're going to see why do we need to write this. If you please go to your handout, page 122. I'm going to erase this. Page number 122, exercise number 9.
I found it.
Huh?
I go to the washroom.
Yes, please, please.
I got on.
Do you know how to
Now look at this one. This is a very interesting example that you're just going to use that thing which you learned. Look at this one. It's a triangle, huh? Yeah. Now, this triangle, you know how to find the area of the triangle, huh?
Yeah.
How to find it?
Base times height divided.
That's right. This is the base. This is the height. You multiply the base to the height, you divide it by 2, right?
Yeah.
And that's how we find the area of the triangle. Now, the question is that the height and base, they are not numerical, not 4 times 3 divided by 2. They are rational expressions. Now, the thing is that to find the area of this triangle using those rational expressions, I want to give you 2 minutes to give it a try and enjoy the problem yourself. Then when you enjoy it yourself, then I just come to just solve it for you. Give it a minute or 2 minutes and be amazed at how math is awesome. Sure. Yes. Yes, John. Sure.
Sorry,
What's the time for it?
That's what I tell you from there. That's what I tell you from there. Basically,
What's the time right there? When you divide right there?
If you multiply that, then you see the term shows up itself. Yeah, but yeah, it's smart. I like that. I like that, Matthew. Smart. That's a good start. Now you kiss it. That's the thing that you do. You write it, then you kiss it. Keep it short and simple. Now, who's done? Not me.
I don't know.
No worries. Take your time. Let me pause the video.
kids to get back on.
No, you do that.
Grab my back to kids and that was really good question.
Guys, please all listen. Now, thank you. Guys, everyone please listen. Daphne and Simone and everyone. Look at this. Now, there was a very good question that Jeremy asked, and he says that because on the question we have to find, I should say, the illustration. And please listen to that because you're going to have something similar on the summative test, which is coming by the November the 2nd. When you just want to find the restriction, you have to look at each individual rational expression, Lisa and Rocco, to find the restriction. The first rational expression that you have is what? The base. You look at the base, I'm going to write this like that. What is the base?
4x squared over x squared minus 16.
That's right. Minus 16x plus 63. That's the first one. And also I have the height, which is 5x minus 35 over x plus 3. When you find the restriction, first look at this. Now you have two rational expressions. Each rational expression is giving you one restriction. You do not simplify this first. Before you tease them, you find the restrictions. The first one gives the restrictions to you when you solve this equation. You say that, okay, I'm going to take a look at this, and I'm taking it to become 0, then I find the restriction. It means that to find the restriction, you solve this x squared minus 16. Let me write it down. I have 25 minutes, huh? Okay, now, look at this. For the first restriction, you say that, okay, I'm going to take it to 0. It gives me the first set of restriction. And also for this, I'm going to do the same thing. I'm going to take this one also go to 0. Then I find the second set of restrictions before I simplify them. I'm going to write this one here first. The first simplification is that I have x squared minus 16x plus 63 equals to 0. You want to solve it to find the zeros. When you find the zeros, it becomes your restriction. But you have two ways to solve it. If you remember from the things that we talked, either you say, oh, I'm not going to bother myself with factorization. I'm going to use a determinant method. Then I say x, the roots, is going to be minus b, which is plus 16, plus and minus b squared, which is 16 squared, minus 4 times a, which is 1, c, which is 63, divided by 2a. My a is 1, then it becomes 2. Now I tell you, God, look at this, 6 to the power 2 minus 4 times 63 square root. Oh, I'm not the man to simplify that. I can't do that. But I'm lazy, and because I'm lazy, I come to find the second option. The second option is this. I look at this expression, x squared minus 16x plus 63. I factor this like that. I say I find 2, because I have x, I write x for each. I find 2 numbers, if you remember from a year ago. Yes, yes. Fantastic.
We couldn't just solve
At least
that?
I say that's so true. Yes.
We could just solve that?
And you can, of course, you use a calculator to solve it. I'm a little lazy. I don't say, oh, 6 to the power 2 minus 4 times 63 square root plus 16 divided by 2. I can find out something easier. I say, if I factor this, not always you can factor it. We are lucky this time we can factor this value. And as Ella said, I can find 2 numbers that their multiplication is 63 and their summation is minus 16. With these 2 numbers, as Ella said, it comes to my mind as minus 7 and minus 9. Then I put them like this. Now, if you multiply these 2, you get the denominator which you have there. Then when it comes to, yes?
So we can only use the a plus b squared when when the last number is a perfect square?
That's right. It's the best way not to just do these calculations.
So if the number was 64, we could use the a plus b.
That's right. Then it's the square root of 8.
Yeah.
Depending, it's 2 times of these 2.
Yeah.
That's right. Good point. And now, in order to find the roots, then I say this one equals to 0. X minus 7 times x minus 9 becomes 0. Yes. Yeah, please. Then, as a result, I have, yes, sir.
Could we like complete the square by saying square minus 6
We can do that. That's right. But this one is much easier. That's right. Now, the zeros becomes how much from here? Either you take x minus 7 becomes 0, which means that x is 7, or x minus 9 is 0, which means that x is equal to 9. Then guys, look at this, Daphne and Simon. The first restriction which I get from this is this. X should not be equal to 7 and 9. This is the first restriction. The second restriction is easier because x plus 3 should not be 0, which means that x should not be equal as minus 3. Look at this. Then before I come to simplify that expression, I only find the restriction. And I didn't use that expression. I didn't simplify that. Found the restriction right back. That's right there. Now we come back to the thing. Any questions so far?
No.
Everyone is happy? So, huh?
I like lasagna.
Me too. I haven't had my lunch yet. When you say lasagna, I feel I'm more starving. I want pizza, lasagna, anything which has so much cheese. Which is bad essentially, not healthy, but I don't know. I have to stop eating those stuff. Yeah, especially pizza, extra cheese. Now, guys, the thing now what we are going to do, first of all, you open your eyes on the problem on the test. When you open your eyes and you see this find the restrictions as I did. The second thing, now we just want to find the area. You know the formulations for the area. The area is what?
Base times height divided by 2.
That's so true. Base times height. Now, yes.
If there's like an unusual shape on the test, will you give us the formula?
Now, if unusual, I give you the formula there. No worries. No problem. And now, for this, the area, I have 1 over 2. What is the base? 4 x squared. X squared minus 16x plus 60. What is my height? Multiplies to 5x minus 35 over x plus 3. Now, also, I remember I have 1 over 2 also to supply this to get the base. Now, guys, look at this. This is a multiplication of 2 rational expressions. What we can do, we can just right away multiply numerator into numerator and divide it by the product of the denominator into denominator. I'm not going to do this because look at the huge expressions that we have. Then after finding the restrictions, I come to each expression. But I mean, keeping it short and simple. 1 over 2 is remaining there. I have 4x squared here. And instead of x squared minus 16 plus 63, I come back again here as Ella said, I write this expression as a factorized format of my denominator, which means that it becomes x minus 9 times x minus 7. The multiplication is 63, the summation is minus 16, and I have x squared. I multiply this to this. Look at this. I have 5x minus 35x. The logical thing which I can do is that I factor 5. Because 5 is a common factor between 5x and minus 35. Then in that case, it becomes x minus 7. Then I have x plus 3. I cannot factor it, then I keep it there. Now look at this. Can you find, Matthew, some... Huh? Oh. Can you find now some factors in there?
Yes.
X minus 7.
Let me see what we have here. Okay, okay. I saw something in there, and I thought that, okay, get it. Now, look at this. Now we have x minus 7 there. We have x minus 7 there, 2 common factors. Then the best thing is that to keep them in short and simple. I factor this, and I factor this, and now I have 2 here, and I have 4. I can factor this to become 1, and I can factor 4 to have it as 2.
What?
2, 4 divided by 2 becomes 2. That's right.
Okay.
Now, the area is how much? I have 2 times x squared divided by x minus 9, which is multiplied into what? 5 times x plus 2. And there we are. That's the area. You can just take one step further and now multiply everything at the numerator to the numerator. Becomes 2x squared times 5 becomes how much? 10x squared. Now I have x minus 9 times
X squared.
x plus 3. And now I finish it. We are done.
Do we expand the?
No, we keep it short and simple because now that we are, we keep it there. We don't expand it. If we do that on the test, it's okay, but the same time. We don't need to do that.
You can still simplify that, can you? If you but you won't.
No.
Pardon me?
No, it's so hard to simplify from there.
But I just do this right then, and then you simplify the bottom.
No, we cannot.
Oh.
Because the bottom becomes x squared minus 6x plus minus 27. We cannot simplify x squared from there to this.
Oh, okay.
Look at this one. Look. If you, guys, everyone listen.
Yeah, you can't simplify anyway, you're right.
Look at this.
What did you?
If I, as Lucas and Robert said, how much time do you have?
We have less than 10 minutes.
Okay. Look at this, Robert and Lucas. Yes, Lisa.
I still like to why you divided 4 by 2.
We can simplify that further because look at this. How come we have x minus 7, x minus 7? We cross
the
them
same
out.
thing.
And we have 2 here, 2 times 2. We cross 1, 2 from there. Because at the end it's 4 divided by 2, then it becomes 2. Then now it's 2 there.
Oh.
You see? You simplify that from 1 on the top and 1 at the bottom.
Okay, I get it.
Now, as Lucas and Robert said, if I just expand the 1 at the bottom, Lucas, if I expand it, I get x squared minus 6x minus 27.
And you can't simplify that.
No, that's right. And everyone listen, it was my problem when I was going to high school myself. Matthew, you cannot take x squared to this because they are added or subtracted. You can only simplify if they are multiplied, not these terms. Then never ever come to say x squared is going to be this. It's impossible. Never think of it.
Yellow. Right away from it.
That's right. Make sense?
Yes.
Yeah, awesome. Correct?
Yeah.
Yeah. Yes, guys, you have 2 minutes for stretching. Yes.
This year, me, can I go on my water
Yeah,
bottle?
sure.
Please stop. Oh my God, is it?
Of course.
That's the way you did it. You don't have to go to that.
What happened to your paper?
What's the thing? What's the year?
Just taking his grades down.
Why? What? Not right.
You're not gonna get out of that right.
Remember the spirit of math as a kid, really smart.
It goes inside, you have still dashboard is simplified by
You must stop.
Get out of here, Matthew.
I don't like it.
How's the concert?
What concert?
What's Justin Bieber song? Why would you carry me? No, go please.
What is it? I'm playing with Twin Notes.
What's that? What's that? Yeah. I rely on you as a partner. Who relies on you? Or your catcher? No, your pitcher.
Yes.
Trust me, because I can't walk. That's okay. What's your symbol? Oh, wait. Yeah, it's a complicated. I have a paper. There's an app that decodes the coaches. No, it's not. When you have like this, when you go like this. This is the worst cause I've ever seen. This time, the fast one was gone on second.
You just do it randomly.
We got on second.
Or do you know what to do
I know what to do. I go fourth.
Oh, horse is good.
I'm just gonna laugh.
You are a lot. That's Robin.
Now, when you play it, left out of you, what do you put?
Yeah, I can play left out.
Yeah.
You play center field. It's so ass.
I mean, that's not play center field. They're outer field.
What's outer field? What's outer field? There's really bad. No. Right field, center field, left field.
Infield.
Yeah, you said left field.
He's just shortstop.
Yeah. I'm a center field. He's studying.
What do you play?
I catch third. Show me your catching position. It's so weird. I go one knee.
Oh my gosh, yeah!
So I just pick a class. I went to camp with him, right? Because it's watch my part.
I do remember that. He would lift his leg high.
What?
Let's
Let's see the random number you come up with. Into 75. You can't put that. Before was 80 last year. For example, I'm the catcher over here. I'm not going to do that. I would. I do this with my you don't believe it. I have.
What do you play? What league? No, like, are you like
Sure, we can go.
Wait, so you play with like,
Yeah.
no way! You do?
Our team is so moving Connor.
I don't even know what they're talking about.
Guys, please take a seat back. Before you leave, I just want to mention something that it takes 1 minute. Please stay for 1 more minute. When we come back next week, I'll expand on it, but for now.
Do you need to write it? Oh no, it's technical.
Listen, we need only 1 minute. Everyone please follow. Simo, Lucas, everyone.
Simo!
Guys, everyone listen. We need only 1 minute to finish this area. When we come back next week, we are going to talk about that more, but now it's a kind of a taster. Look at this. If you have A divided by B, we talk next time. That's right. We multiply that. Always
How
remember
do you
this.
know that?
That's exactly like that. A division turns to multiplication provided that you invert the divider. For example, if you have 3a minus 6 over a plus 2 divided by a minus 2 over a plus 2, it's essentially like that. You write it like this. Please have a look like 3a minus 6 you keep the a as the way it is, which is a plus 2. Then you multiply that. You see the beauty? You change the division into multiplication, but the divisor is reversed. Then you multiply that, the reverse of this. You change the basement to go to the roof. You take the roof coming to the basement, which becomes a plus 2 over a minus 2. And now you see that this is a multiplication. Now we can see the common factor, a plus 2 here, a plus 2 here. We can kiss them. Now we get the last thing is 2, a minus 6.
Oh, an A minus.
A minus 6 because I factored 3 from this. Then you see these ones goes, a minus 2. And
Oh.
right, what's the homework for you? Please during the weekend remember to do your homework.
Thank you.
Don't worry, we got it.
Oh,